go. All right, cool. So today we're going to talk about conics. Now, ladies and gentlemen, this is not really that shocking. We talked last time about how do we make all of these conics. You have two cones. If you take the samurai sword and go totally horizontal, he flops off and there's circle cross sections, right? If we go to Austin and we're like at an angle, okay, it's an ellipse section of Austin. Okay, if we just kind of do a glancing blow, we get a parabola. If we go right down but not on center line, we have hyperbola. And of course, if we go straight down the center, we get a line. Okay, so those are the ideas. So if we're going to slice it this way, we're going to get an ellipse is what we're going for. Now, there are basically two things. You have to know and be able to do with an ellipse. So here we go. Get those grades checked?
Yeah.
Okay, well, you can ask me during homework time. Be happy to talk to you. All right, so with this, x minus 3, the quantity squared, plus y minus 4, the quantity squared equals 3 squared. Tell me how to graph that. By the way, what shape is that?
A circle.
It is a circle. With center where?
3, 4.
1, 2, 3, 1, 2, 3, 4. And that's right, because it's x minus h, right? Okay. Now, which way? How far is radius? 3. 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So we're like, woo! All right, there it is. Circle. Yeah. Now, if it were in the formula, it could be listed as they could be listed as 9. But if I want to know the radius, that means I would have to say, oh, r squared equals 9. Correct. R equals 3. Very good. All right. So this is all good. This is all good in the hood. Now, could I do this? Well, I guess I should have done that a minute ago. Plus 1 minus 4 equals 1. Is that the same exact thing as we just had? What's the only thing I did?
3 squared.
Yeah, that's it. So instead of having 3 squared over here, I just divided both sides. Just a second. By 3 squared. What's 3 squared divided by 3 squared? 1, because it's the same thing. And it's 3 squared. It's all good. How much do I go in the x and y part? 3 each way. Does everybody agree? How much do I go in the y part? 3 each way. That makes it a circle because it's nice and balanced. Are you good with that? Okay. If, on the other hand, you have this, we'll change it just. All right. What if we have now what shape is it? Ellipse. Why?
Because one side's stone taller than
That's it. That's the answer.
No.
They're not the same. If they were the same, it's a
Circle.
If it's not the same, it's okay. Where's the center? 3, 4. Same stuff, right? Okay. How far do I go in the x?
Oh.
So do we agree with that? How far do we go on the y? Can everybody do that? Everybody okay with that? We probably ought to get some names though here. Let me get some names. This is still the center. Does that seem reasonable? Okay. And in a circle, the radius is the same no matter where you go. But in this, you have a minor axis, and you have a, guess what?
Major axis.
I'm going to go major, yeah. Okay. How come major and minor?
Because the minor's the little one.
Rocket.
So if it was smaller on
So you could totally have an ellipse that looked like this, And the major would go this way, and the minor would go that way. No, major is whatever way is the bigger way, that's major. Whatever way is shorter, that's the minor. Now, this, by the way, is called the semi-minor axis. Semi-minor. Why is it called the semi-minor?
Because it's not,
Because it's just half of it.
so it's not, there's no radius.
Because every radius is going to be slightly different, isn't it? So you just figure, oh, what's it this way, good enough. Get the idea? So semi-major, semi-minor. Okay, so here we go. X plus 2, the quantity squared over 3 squared, plus y minus 4, the quantity squared over 1 squared equals 1. Okay, let's graph it. Michaela, give me, where's the center? No. This is not allowed. Look up here and tell me what goes with X and what goes with Y. 2, there we go. So we got a 2 and a 4. Now, is this positive 2 or negative 2, folks? Negative. Why is it negative 2?
What's the sign?
Okay, because it's normally X minus H, quantity squared. Since I see a plus, what got put in there? Negative 2. Okay. This is Y minus K. So what got in there? Positive 4. Everybody good with that? Okay. 1, 2, 1, 2, 3, 4. Okay. Southern, tell me something.
You go one to the right and one to the left.
One to the right and one to the left.
Wrong.
Because that's like the minor thing.
Oh, look what's together. What do I do in the X direction?
Never mind.
What do I do in the X direction?
3.
3. Now, that happens to be the major, doesn't it?
Yep.
Do I frankly care? No, it's just the bigger one. Okay. What do you got, Connor?
It's up and down 1.
I agree with you. There's my minor. How come?
It's shorter.
That's it. And then dots, la, la, la. There it is. So hold on. There is technically one other thing. Unlike a circle that has a center right in the middle, okay, and everything is based around the center. Does everybody agree? What would happen if I snap that center and I stretch it this way? What's going to happen to this shape if I stretch the centers apart? It's going to go like, oh, so like an ellipse, it's like the centers are coming apart. Well, we still have to have the center, so we can't call it that. But there's definitely something in here-ish and in here-ish that are the focus of the ellipse. But anytime I talk about two focuses, it's called foci.
I was about to say the foci, but it's not foci, it's foci.
Foci. Yes.
I think you kind of lost me on that part.
Think about it this way. If I have a magnet right here, what's the magnetic field look like in 2 dimensions? A circle. Do you agree? What happens if I snap that magnet and I pull those magnets apart? What's going to happen to that magnetic field? It's going to go like this, correct? So the magnets, in essence, are the foci, the focus of that magnetism. So take this and just peel it apart. That takes what was a circle
So you just kind of guess for those.
and makes it an ellipse. You don't guess. Here it is, though. This is easy. Okay? It's a squared minus b squared equals c squared. Yes. Now, what is that real similar to? A squared plus b squared equals c squared. What are a, b, and c? Well, here you go. X minus h, quantity squared, plus y minus k, quantity squared equals 1. Everybody's cool with this, right? If this were a circle, what would be underneath here? R's, correct? Right, r squared, good call. In this case, a squared and b squared. Here's the only thing that makes a difference. Sometimes this is B, sometimes this is A. How do I know? A is bigger. That's it. So whichever one's bigger is A. Why would that make sense in this formula? A minus B. I want big minus, look. Okay, so x minus, what the heck, okay, 2, plus 2, plus y minus 4 equals 1. This was 3 squared right southern and 1 squared. What's A? 3, so I'm going to square it. What's B? So I'm going to square it. Okay. So I got 3 squared minus 1 squared equals, so that's 9 minus 1 is 8. So what does C equal? Square root of 8. Why does C equal the square root of 8? Right. Because it's C squared goes with 8, correct? So when I had this over here, and it was, right, I would go this much square root of 8 and this much square root of 8, and those are my foci. That's it. Okay? That is graphing. Can everybody find the center of the ellipse? Can everybody know how much to go left and right and up and down? Can everybody draw the ellipse around it? Can everybody tell which one's major, which one's minor? Okay, the only thing that might be a little bit challenging is maybe the focus thing yet, right? Okay. Remember, we're just getting started here. That's one thing you have to be able to do to it. What about this? What shape is that? Well, we don't know necessarily, because what do we have to do to put this like we want it to graph? Carmen, does this look like the equations we've been graphing thus far today? It does not, because it's not in squares, is it? So I need to complete the square. You ready? Let's do it. X squared minus 2x plus blank. So can I put the x's together? Does that make sense? Okay, so what am I probably going to do next, Carmen? Do what with the y's? Probably going to put them together. Okay. Everybody okay with that? All right, Carmen, how do I complete the square if I got a little negative 2 here? You're so close. Take the 2, cut it in half. What's half of 2? Good, square. What's 1 times 1? Good. So I'm going to put plus 1 here, but what do I have to do? Keep it balanced, right? Okay, what am I going to do here, Austin? No, that's something to do. What do we do with this middle number? What did Connor just tell me a minute ago? Complete square, so I'm going to take 4 and perfect. That's A. Then what am I going to do that to? Square it, close, which is, but now what do I have to do? 4. All right, so in this case, what do I get here? And what do I get here? He's so close. Minus 1. How come it's minus 1? Because I got to have the middle. What's this one? Plus what? Yes, y, guys. X minus 1, x minus 1, x times x squared. Minus x, then what's negative 1, negative 1? Plus 1, do you agree? Does that make negative 2x and plus 1? Over here, y plus 2, y plus 2, y times y is? Then I have how many? 2. Plus, which makes? What's 2 times 2? There you go. Is everybody okay with this? Okay, equals 13. Now, what shape is it now? Can everybody tell me what shape it is now? It's a circle. How come it's a circle? Is it the same number under both pieces? So it has to be a circle. Now, by the way, the radius would be square root of 13, which is about 3.2. How do I know that? Just square root of 13, right?
Can you put a decimal in for?
Do not. No. Now, what you could do is you could do this. Like if that helps you remember. Because is that the same thing? Now, we're going to change this slightly. Okay, what's the difference between this problem and the problem we just had? Okay, I changed 16. But if I just had x squared with a 16, would that still just be a circle? Yeah. The problem is, I have this 8. Can I complete this square like always? Cut this in half, the answer is 2, square it, add, okay. Over here, how come I can't complete the square yet? The 8. What do I have to do before I can complete the square?
Divide by.
That's right, I'm going to take an 8 out. Do you agree with that? Now, what do I do with 2?
Cut it in half.
Cut in half, because this is just a 1, right? So cut in half, 1. Square it, 1. What do I put on the other side though?
1.
No. Southern. I put a 1 in here. What do I put on the other side?
8.
Why?
Why? Because it's outside.
Because if I put this right back, this would go back to being 8 squared, wouldn't it? 8 squared. This would be back 16, wouldn't it? When I put a 1 here in the parentheses, what did I really put on this whole side? 1 times 8.
So really it's.
So I get this, 8, x plus 1 squared, plus y plus 2 squared. What really is out front here? Equals 20, correct? Okay, now what happens when I divide? Connor?
It would be.
That turns into 1 like it should, correct? This is going to be square root of 20 each way. Unfortunately, what's this?
8 times that.
You got these two, you got to divide, correct? So to make Connor feel better, let's give him a decimal here, because the 8 and the 20 are going to cancel out with each other, correct? So this is going to be 2 over 5. So in this case, this is x plus 1 over 2.5 plus y plus 2 over 20 equals 1. Is this a circle or an ellipse? Ellipse. Okay, it's an ellipse because the bottoms are not the same. So that's the first thing we got to do. If I gave you something in the correct form, could you find the center, go each way? Okay. If I give you this, should you be able to, at this point in this class, be able to complete the square? Put it away. I should be able to complete the square, correct? I'm going to use completing the square to make these ellipses. Now, to be fair, this is a nasty little problem because it's got these little decimals in it. What would the center be? Perfect. -1, -2. How far do I go in the y direction? Square root of 20. What's the square root of 20? About 4.2, sure. So we're gonna go up 1, 2, 3, 4, and a little bit. 1, 2, 3, 4, and a little bit. How far in the x direction do we go? We're gonna square root it. Square root of 2.5. Ooh, that's like 1 point something. So a little bit and a little bit. There it is. There's my ellipse. Okay? Now guys, that's a lot. Quickly. Was the first half easy to do?
Yeah.
The only thing that makes the second half harder to do is you guys are not amazing at completing the square. Okay? You're gonna have to though. We've done it in class, we've done it repeatedly.
We have like a whole section on completing
Yeah, we did. You would have thought somebody planned ahead for that. We did. Did some of you blow it off? Yes, yes, you did. But guess what? It's back. Okay, it's like a bad toe fungus. It's back.
I feel like after a good amount of practice, we'll probably be fine.
I think after a couple, you're going to be just fine. I agree with that. Now, so you'll notice for these ellipses, that's circles. Here you go, ellipses. 1, 2, 3 parts. I went through it very quickly today, correct? This goes through it much more slowly. But let's be honest, if I went through it more slowly in here, what would happen? People drooling on the desks, okay? So your goal over the next, see here, by Wednesday, actually, let's be honest here. Control C, Control V. How come it didn't take the little words? Control C, Control V. There you go. So let's make this one do Wednesday. And this one do Wednesday. And this one, oh, so sweet that you think that. Thursday. Because you're here twice this week. What?
Oh, yeah.
Huh? But we're not very many Delta masses unit.
Nope.
Why?
Zach doesn't focus on it in his class, and so he didn't make a ton of conics stuff for it.
Is that like the creator of Delta?
Yeah, Mr. Korzig. Okay, so do Thursday and Control C. Monday. Be the 10th. There you go. All right, so I will warn you, these are fairly long. 12 minutes. It's not amazing, I'll agree. I think these are the ones that are 12 minutes.
Then why'd you make them that long?
But that one's only 4 minutes. How long is this one then?
When did you have
That one's
facial
5
hair?
minutes. What?
When did you have facial hair?
Before I put the doors up on my closet.
So a while ago.
Yeah, it's been a while. 2014? No, it's after that because I was, just a second. How fat am I? Nope, that's definitely, yeah, it's definitely later than that. No, by 2012, I was 60 pounds lighter than I am now, something like that. So then my daughter came along and then, you know, Lots of fun. All right, so that's due Wednesday. That's due Wednesday. That brings us to here. How long is this one? That's 5 minutes. You know what? It's not that bad.
Well, I think-
Yeah, we'll leave it. All right. Because you can always start on this. All right. So there we go. Those are the pieces that are due for the week. Guys, this is not going to be easy. You're not going to be able to just not do it and then try to figure it out maybe later near the end of the chapter. Like I'll get to it later and I'll kind of do it when I have to try to maybe pass. This would be a really poor section to use that logic on. This is one you want to do as we do it so that I'm here to help you. Do you understand? Okay. All right.